Welcome back friends. Welcome back to another video session from this channel, and in this video session we are going to study about the elongation phase of the translation mechanism in case of eukaryotes, right? So in the previous video session we have studied about the initiation phase of the translation mechanism in case of eukaryotes, and in this video session we are going to discuss about the elongation phase of the translation mechanism which occurs in case of eukaryotes, right? So here during the elongation phase of the translation mechanism in case of eukaryotes, for the successful organization of the elongation phase of the translation in case of eukaryotes, there is a requirement of certain elongation factors, and these elongation factors, they are nothing but what? Eukaryotic elongation factor 1 alpha, eukaryotic elongation factor 1 beta gamma, and the other one is eukaryotic elongation factor 2. So these are the various elongation factors which play a prominent role for organizing the elongation phase of the translation in case of eukaryotes. And these specific elongation factors, they are quite homologous to the elongation factors in case of the prokaryotic translation mechanism, right? That means eukaryotic elongation factor 1 alpha, it is quite homologous to EFTU elongation factor in case of prokaryotic translation mechanism. And eukaryotic elongation factor 1 beta gamma, it is quite homologous to EFTS of prokaryotic elongation phase, right? Prokaryotic elongation phase. And eukaryotic elongation factor 2, it is quite homologous to the specific elongation factor known as EFG of prokaryotic translation. So these are the various elongation factors which are responsible for organizing the elongation phase of the translation in case of eukaryotes, right? So here before studying the activity of individual elongation factor in detail, at first let us have a look on the organization of ATS pre-initiation complex, right? So let us assume it as the ATS pre-initiation complex, right? So this is the eukaryotic mRNA, and here the small subunit of the ribosome, it is recruited here with its three respective sites, A site, P site and E site, right? And here the large subunit of the ribosome, it was recruited here, right? And initially during the initiation phase of the translation mechanism, in case of eukaryotes, the initiated tRNA with its encoding amino acid, it was successfully recruited here, right? Initiated tRNA with its encoding amino acid, it was successfully recruited to the P site of the ribosome. So here the small subunit of the ribosome, and the initiated tRNA with its encoding amino acid, and as well as the large subunit of the ribosome, it eagerly waits for the successful eloquence of a specific tRNA known as what? Amino acyl tRNA. What it is? Amino acyl tRNA with its encoding amino acid. Amino acyl tRNA with its encoding amino acid. So this is nothing but what? Amino acyl tRNA, right? Amino acyl tRNA with its encoding amino acid. But for the successful recruitment of the amino acyl tRNA with its encoding amino acid to the A site of the ribosome, a specific elongation factor is required, and that specific elongation factor, it is nothing but what? Eukaryotic elongation factor 1 alpha. What it is? Eukaryotic elongation factor 1 alpha. So this is the specific elongation factor which is responsible for the successful recruitment of the amino acyl tRNA to the A site of the ribosome. So here before to the recruitment of the amino acyl tRNA with its encoding amino acid to the A site of the ribosome, here I need to mention you one thing. What it is? About the kinetic proofreading mechanism. What it is? Kinetic proofreading mechanism. So what is kinetic proofreading mechanism here? So kinetic proofreading mechanism, it is nothing but before to the successful recruitment of the amino acyl tRNA with its encoding amino acid to the A site of the ribosome, a specific elongation factor known as what? EF comes into the picture, right? EF, right? So EF is the specific elongation factor. Which is responsible for holding up of EF is the specific elongation factor which is responsible for holding up of the specific tRNA with its encoding amino acid, right? So let us assume it as the specific tRNA with its encoding amino acid. Right? So here what exactly happens during the kinetic proofreading mechanism? Before to the successful recruitment of the amino acid tRNA with its encoding amino acid to the A site of the ribosome, a specific elongation factor known as EF it comes into the picture, and it will monitor the correct recruitment of the amino acid to its encoding tRNA. That means before to the successful recruitment of the amino acid with its encoding tRNA to the A site of the ribosome, at first the specific amino acid with its encoding tRNA, it gets associated with a specific elongation factor known as EF. EF in association with GTP, it gets successfully recruited to the amino acid and as well as its encoding tRNA. So here the specific EF which is in association with GTP, it will monitor the correct base pairing. It will monitor the correct base pairing in between the codon of the mRNA, right? The specific elongation factor which is in association with GTP, it will monitor the correct base pairing in between the codon of the mRNA and as well as the anticodon of the tRNA. For suppose if there is a correct base pairing in between the codon of the mRNA and the anticodon of the tRNA, under such condition, the specific elongation factor, it comes to a conclusion that the specific amino acid which was recruited to the tRNA, it is the correct one. Under such condition, the specific elongation factor which is in association with GTP, it undergoes GTP hydrolysis and it remains in inactive conformation, right? So after the successful dissociation of the elongation factor which is in association with GTP, now the specific amino acid which was recruited to the tRNA, it is capable to participate in the polypeptide chain synthesis or in case of the protein synthesis, right? So here for the successful recruitment of the amino acid tRNA, with its encoding amino acid, there is a requirement of a specific elongation factor, and it is nothing but what? Eukaryotic elongation factor 1 alpha. So the specific eukaryotic elongation factor 1 alpha, it is quite homologous to EFTU of the prokaryotic translation mechanism, right? The specific eukaryotic elongation factor 1 alpha, which is an elongation factor, it takes the advantage of one GTP molecule. So by taking the advantage of one GTP molecule, the specific eukaryotic elongation factor 1 alpha, it is capable to recruit the amino acid tRNA with its encoding amino acid to the A site of the ribosome, right? A site of the ribosome. So this is the amino acid tRNA with its encoding amino acid. So once when the specific elongation factor, when it has delivered the amino acid tRNA with its encoding amino acid to the A site of the ribosome, under such condition, it lead to the activation of the peptide bond formation in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid, right? After the successful recruitment of the amino acid tRNA with its encoding amino acid to the A site of the ribosome, now it leads to the activation of the peptide bond formation in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid, right? So let me present you the peptide bond formation which takes place in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid, right? So in case of prokaryotes, if you recall, the initiating amino acid, it is a formulated amino acid, right? But whereas in case of eukaryotic translation mechanism, the initiating amino acid, it is not a formulated amino acid, it is a normal amino acid, right? So here, so let us assume it as the initiating amino acid, right? Initiating amino acid. And it is nothing but the amino acid tRNA encoding amino acid, right? Amino acid tRNA encoding amino acid. So here in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid, initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid, the peptide bond formation takes place, right? Amino acid tRNA encoding amino acid, right? So this is nothing but amino acid tRNA encoding amino acid, right? So here, exactly here the nucleophilic attack or the nucleophilic cleavage, it takes place, and in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid, the peptide bond formation takes place, right? Peptide bond formation takes place. So something around like this, right? So this is nothing but the amino acid tRNA encoding amino acid, right? So here the specific oxygen atom which is a part of the carboxyl group of the specific amino acid which is in association or which was encoded to the initiated tRNA, here the specific oxygen atom, it had undergone nucleophilic attack or the nucleophilic cleavage, right? So once when the specific oxygen atom, when it had undergone nucleophilic attack or the nucleophilic cleavage, now here the specific oxygen atom, it is removed and it is replaced by the nitrogen atom which is a part of the amino group of another amino acid, right? So here easily you can understand here the specific oxygen atom which is a part of the carboxyl group of the specific initiated tRNA encoding amino acid, it had undergone nucleophilic attack or the nucleophilic cleavage and it is replaced by the nitrogen atom which is a part of the amino group of another amino acid. So in between the two amino acids, the peptide bond formation was took place, and in order to organize the peptide bond formation in between the two amino acids, there is a requirement of a specific enzyme, and that specific enzyme, it is nothing but what? Peptidyl transferase. What it is? Peptidyl transferase. So here the peptidyl transferase activity, it is a part of a specific RNA and it is nothing but what? 28S rRNA. What it is? 28S rRNA. So in what way? For organizing the peptide bond formation in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid. In case of the prokaryotic translation mechanism, the specific mechanism, it has taken the advantage of a specific rRNA. It is nothing but what? 23S rRNA. So the specific 23S rRNA, it is a part of the large subunit of the prokaryotic ribosome, right? In the same way, in case of the eukaryotic elongation phase, for organizing the peptide bond formation in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid, the specific elongation phase of the translation mechanism in case of eukaryotes, it takes the advantage of a specific rRNA and it is nothing but what? 28S rRNA. So here the specific 28S rRNA, it is a ribosome, right? What it is? Ribosome. So what is the meaning of ribosome? The specific ribose nucleic acid, which is in association with or which possess the enzymatic activity or catalytic activity. So specific ribose nucleic acids, they are considered as ribosome. So here the 28S rRNA, which is a part of the large subunit of the eukaryotic ribosome, it possesses the enzymatic activity or catalytic activity, and it is nothing but what? 28S rRNA. So by taking the advantage of 28S rRNA, here the peptide bond formation, it was took place in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid. So after the successful formation of the peptide bond formation, now here what exactly happens here? So let me present it here. So after the successful formation of the peptide bond in between the two amino acids, in between the two initiating amino acids, then after in the very next step, one more other elongation factor, it comes into the picture, and it is nothing but what? Eukaryotic elongation factor 2. So what is the role of eukaryotic elongation factor 2? The specific eukaryotic elongation factor 2, it is quite homologous to EFG of the prokaryotic elongation phase, right? In what way? For organizing the translocation of mRNA in case of the prokaryotic elongation phase, the specific mechanism or the specific process, it had taken the advantage of EFG. In the same way, for organizing the translocation of mRNA, the specific mechanism or the specific process, it takes the advantage of a specific elongation factor, and that specific elongation factor, it is nothing but what? Eukaryotic elongation factor 2. So by taking the advantage of eukaryotic elongation factor 2, which is quite homologous to EFG of the prokaryotic elongation phase. Now here exactly what happens here? The specific initiated tRNA with its encoding amino acid, which has participated in the polypeptide chain synthesis, or in case of the protein synthesis, it gets successfully translocated from P site to the E site, right? So once when the specific initiated tRNA, when it was participated in the polypeptide chain synthesis, or in case of the protein synthesis, now the specific initiated tRNA with its encoding amino acid, or the specific initiated tRNA which was recruited to the P site, it gets successfully translocated from the P site to the E site, right? So from P site to the E site, the specific initiated tRNA, it was successfully discarded. So once when the specific initiated tRNA, when it was got successfully discarded from P site to the E site, now the P site of the ribosome is free. So here, in order to occupy the P site of the ribosome, now the amino acid tRNA initially which was recruited to the A site of the ribosome, it gets successfully recruited to the P site, right? So once when the specific amino acid tRNA, when it was got successfully translocated from A site to the P site under such condition, now the A site of the ribosome is free here. So in order to recruit, again the amino acid tRNA with its encoding amino acid to the A site of the ribosome, again there is a requirement of a specific elongation factor, and it is nothing but what? Eukaryotic elongation factor 1 alpha. What it is? Eukaryotic elongation factor 1 alpha. So by taking the advantage of a specific elongation factor known as eukaryotic elongation factor 1 alpha, now the specific amino acid tRNA with its encoding amino acid, it is capable to recruit to the A site of the ribosome. But the specific eukaryotic elongation factor 1 alpha, it is in inactive mode, right? So as I have already told you, when the specific eukaryotic elongation factor 1 alpha, when it is in association with GTP, it remains in active mode, right? And once when the specific eukaryotic elongation factor 1 alpha, when it successfully delivers or when it successfully recruits the amino acid tRNA to the A site of the ribosome, under such condition, the specific eukaryotic elongation factor 1 alpha, which is in association with GTP, it undergo GTP hydrolysis and it remains in inactive conformation, right? So under such condition, to regain the active conformation or to regain the GTP moiety, the specific eukaryotic elongation factor 1 alpha, it gets associated with one more other elongation factor, and it is nothing but what? Eukaryotic elongation factor 1 beta gamma, right? So let me write it here. What it is? Eukaryotic elongation factor 1 beta gamma. So by taking the advantage of eukaryotic elongation factor 1 beta gamma, which is an guanine nucleotide exchange factor, the specific eukaryotic elongation factor 1 alpha, which is in association with GDP, it undergoes successful displacement with what? GTP. So once when the specific eukaryotic elongation factor 1 alpha, when it acquires the GTP conformation, again it is capable to recruit the amino acid tRNA with its encoding amino acid to the A site of the ribosome, right? So this is nothing but the amino acid and it is nothing but amino acid tRNA, right? So again the specific amino acid tRNA with its encoding amino acid, it gets successfully recruited to the A site of the ribosome, and in between the specific peptidyl tRNA with its encoding amino acid at the P site of the ribosome and the specific amino acid tRNA with its encoding amino acid which was recruited to the A site of the ribosome, again the peptide bond formation or the polypeptide chain synthesis takes place. So here these series of sequence of events, they will continue until the small subunit of the ribosome, it is about to reach the stop codons or the termination codons, right? So these series of sequence of events, they will continue until the small subunit of the ribosome, it is capable to recognize the sense codons or the normal codons which are present in case of the eukaryotic mRNA. And once when the specific small subunit of the ribosome, when it is about to reach the stop codons or the termination codons, the specific stop codons or the termination codons, they are present very nearer to the 3' end of the eukaryotic mRNA. So once when the specific ribosomal subunit, when it is about to reach the stop codons or the termination codon, under such condition, the polypeptide chain synthesis, it gets inhibited, right? So this is about the elongation phase of the translation mechanism in case of eukaryotes, right? So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day, right? Thank you.